Lecture 2, Segment 1, Creating Orthographic Views from Isometric Views with Curvature. Before we jump into this week's lecture, here's another segment on hand sketching to further reinforce our good visualization skills. And this time we're going to do something very similar to last week where we took that isometric view, you'll remember. In fact, I still have it here. Here it is. Remember, we took that and we drew our 3 positive principal orthographic views. There they were. But now what I'd like to do is I'd like to do one with a little bit of curvature, and that makes it a little bit trickier. Just like we did last time, I'm going to start out by figuring out its size. And I've already done that, and let me show you how I did it. Now, this sketch is not the world's finest. This is something somebody drew up for me. I copied it over very quickly, and, it's not perfect, but we get the idea. What I want to do is capture its size very quickly and lay out what it would look like in an engineering drawing. My axes, here's Y, here's X, here's Z. That needs to become automatic. Once you get it automatic, then you can count very quickly. X is going to be 1, 2, 3, 4, 5, 6. Z is easy, it's 4. What about Y? Y comes up to this top here, which is kind of, drawn in, and it doesn't look very good. But I get a pretty good idea here. I know it comes up 3, 4, 5, and that gets me to the center here. And note that the center of this hole seems to be the center of this top arc as well, because that's where the curvature starts. So I'm guessing is that that's too high from this center, 1, 2. And it's not a guess, it's something I actually know. So it's 3 plus 2 plus 2. Well, 3 plus 2 is 5 plus 2 is 7. So Y is 7. And that becomes my overall dimensions, 6 by 7 by 4. So let's take a look and see if we can't do something with that. I've already started my hand sketch for you. I've labeled it. I've filled in my title blocks appropriately. I'm going to hope that you do as well. And then I'll just start sketching in. And this time I'm not going to draw any X's or any labels. I want to make it a little more pristine for you so you get the idea. So we said that the front view in this particular object was 6 by 7. So let's draw that in. Oh. So 6 by 7. And let me just go over. I don't want to go over too far. I'll just go over 4 spaces again. And my right view, which is my YZ view, is 7 by 4. So here's my 7 already. 1, 2, 3, 4. And then finally, my top view. And again, that's going to be my Z, which is 4. So there's my layout. You might ask me, gee, couldn't we do this 2-to-1? And we could almost do it. It would almost fit. It'd be a little large, though, going up 14 here. That would be a little bit large. It would really be crowded on the paper, so I'm still using it as 1. But you might think about that before you did it on this one. It's still, I think it'll be big enough. We'll be able to see it. Plus, I'm going to zoom in a little bit, and that'll help. Let me get out of the way, and let's just take a look and see if we can't make some sense out of this. Our front face, again, which is our XY plane here, is just a simple L shape. And let me just draw that in, and then we'll talk about it for a moment. And it comes up 3, and over 3, like that. See, there it is. Now, this curvature, this curved surface, is nothing more than projection as what? A flat surface. Let me show you there what I'm talking about. Here's a curved surface, right? But if I put it on end like this, and I keep backing up and backing up, backing up, it looks straight to you in 2D. You lose the curvature, right? It doesn't, you see it this way, but you don't see it this way. You just see a piece of paper. You just see the frontal area here, and there it is. So that's how that curved surface, just like an inclined surface, we just see a piece of it. We see a leg of the triangle. Very similar here in the curve. We see the frontal area, that's called. And that actually is a term that gets used a lot in engineering for all sorts of different things, and we use it here to just be that's that area that we see from this particular view. But we're not done with this view yet, are we? Because we have the circles, and I'll show you how we deal with that. We know that where that's located, we know that right here, between here and here, that hole, we're assuming it goes through, So we draw with a hole. We actually draw the top and bottom line. As if our X-ray vision, we could see that that tube was going through. And to make sure that everybody understands that that's a hole, that that's what we're dealing with, we use a special notation in these sketches and engineering drawings as well. We do what's called a center line. The center line is drawn as long, short, long. And then if you needed more, you could go short, long, as long as you needed it to go through the length of the hole. By pulling the center line beyond the solid, that indicates to the reader of this engineering drawing that this hole, in fact, goes through the entire portion of that part. That's what that means. So drawing a center line through the part like that has a very specific meaning. It means, in fact, that that hole goes all the way through. We also see that here because, remember, we see the fact that the dashed lines are connected. But we go one further. We show you that that, in fact, is the case, that we pull this line through. It's a through hole. If we have a center line running through an entire part, that indicates a line of symmetry. Now, this part doesn't have that, but that would be another example of running a center line through. All right. That view wasn't very interesting. Neither is the top view. Top view is kind of dull. In fact, the top view is about as dull as they come. It's this. There it is. And I'll leave you to sit and figure out that that's right. The right view is a little more interesting. We have this segment here, just this face. And then here on the back, we go up to, then we have to draw that piece of arc. And in the center here, where we'll denote with a little X, and I'll put 4 tick marks there to indicate where the hole goes. Now, if you have a compass, this is easy. Very simple. But you don't always have a compass with you when you're out in the field or wherever else. So what you can do is take a piece of paper. Yeah, I just got a nice little piece of paper here. You can build yourself a template. Watch this. You can just go, okay, there's my template. And I can now add some more control points to draw my circle, and it will look a lot better. And you might say to yourself, well, why would I do this? Well, I tell my instructors that if I don't see this on your hand sketches, you lose points. So that's one good reason to do it. The other is, again, it gets you the discipline. And discipline is good for the soul. So it gets you thinking like an engineer. Okay, so there's that one. And I'm sorry that that left out of view for a moment. Let me do another one here. And you can see I can just build myself some control points. And now when I go to sketch that, it doesn't look too bad. That is certainly a little whopper jawed on a hole. But it doesn't look too bad, especially if we zoom out. You see, the farther you zoom out, the better it looks. There you go. Now, to finish this, some people would tell you you should pull that cross with a set of 4 additional lines around it like that. I'm not going to hold you one standard or the other. That is something that is used in that, often used. You see it in a lot of older drawings, but it doesn't really matter one way or the other. But what you now have is we've taken this sketch of a solid and we've laid it out in its 3 principal orthographic views using glass box. You'll notice that everything all lines up again. But what we've done is we saw the additional trick of using a little template to help us make our curvature a little nicer. And it comes out very, very nice. So there you now have going from isometric to orthographic. What we'll do for the next 2 hand sketching sessions is we'll go from these orthographics, we'll go back to the isometric. So we'll turn it around and go the other way.